Next theorem says if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. This is a converse of BPT. We call it as a converse of BPT. What exactly it says is that if we have a triangle and we draw a line, okay, we don't draw a line, okay, it is given that AD upon DB is equal to AE upon EC, then D is parallel to BC. Earlier we had what? If the line D is parallel to BC, then AD upon DB will be equal to AE upon EC. That was the theorem we had. Now they are asking, there is a line DE intersecting the two sides AB and AC of the triangle, but it is not mentioned that D is parallel to it or D is parallel to BC. We have to but they have given that AD upon DB is equal to AE upon EC. So we have to prove that they are parallel. So what we can do is we can use the theorem only to prove it. So we do not know it is parallel or not. So in that case we'll say, okay, fine, we do not know. Let us draw a line DE dash which is parallel to BC. So what is our assumption? Assumption is that D is not parallel to BC, and then we will prove that I was wrong in it. So what I'll do is I will draw. So what is the construction that we have to do? Construction. Construction. And what is the construction that we have to do? Draw DE dash parallel to BC, after assuming that D is not parallel to that. So according to BPT theorem, what do we have? AD upon DB should be equal to AE dash upon E dash C. Are you getting my point? This is, if I draw a line parallel to BC, then AD upon DB must be equal to AE dash upon EC. This is by theorem, right? Or we can say by BPT, or write here BPT instead of writing there. Now, what they have given you, but they have given what? AD upon DB is equal to AE upon EC. They have given you. This is given to us from the question. A line divides any two sides of the triangle in the same ratio. They have given. Then is it possible? It is possible only when you can see AD upon DB is equal to AE dash upon AE dash C, and they have given AD upon DB is AE upon EC. So this is possible only when AE dash upon E dash C is equal to AE upon EC. And for that, what should happen? For that, E dash should coincide with E, then only it can happen. Which means our assumption that we had that AE dash, okay, assumption that D is not parallel to BC was wrong, and we can say what? That is DE, okay, we can write as is coincide. When they coincide, what will happen here? DE is the same as DE dash, okay. So it means DE is now parallel to BC, and hence it is proved here. So remember what we did, we assumed that yes, that okay, D is not parallel to BC, and then we drew a construction saying let DE dash be parallel to it. So we applied the theorem and we found that according to the theorem, E and E dash cannot be different. It has to be the same. Is that okay? Why? Because AD upon DB is equal to AE dash upon E dash E, and AD upon DB was given as AE upon EC. So this can't be possible. So this is why E and E dash should coincide. Means D should be the same as D dash, and then it is proved here.